Hi everyone, myself and Arun Kumar from SNS College of Technology. In this video, I am going to share about minimization of Boolean expression and its techniques. So these are all the slides we are going to see in this video. Introduction: digital electronics are playing a vital role in our daily life because minimization refers to the process of simplifying the Boolean expressions or logic searches. And moreover, in home itself, we are using sensors-based devices, especially for Alexa devices. It is also having a more number of sensors. So, in order to get the power for sensors, we need to reduce the number of gates as well as the complexity and power consumption and delay. So these need to be considered while designing a project or devices. And minimization technique is very efficient for combination circuits and VLSI embedded system and low power IoT devices. So here the example is low power IoT devices. And the objective is reduce the cost, improve speed and low power consumption and simplifying the test. The low power consumption means so the device which are to be used in the connections are having a same power for all the devices, or else the power failure will be happen and it may not be tested or it may not be worked. And the cost also decrease because each gate requires some minimum number of costs, so that we can use some more number of applications. And moreover, it can be used for improved speed because sometimes if the device get failure, then automatically the speed also reduce. We need to check the speed also. Properties. So some of the properties they are given based on the Boolean algebraic equations. So the here a is a variable, and in the next slide we are using other variable also b. So because it's a theorem based properties, a and b is used for input signals, so that we can make it as a input by zeros and ones. So let me see this will be happen for the properties. Identity law: a plus 0 equal to a and a dot 1 equal to a, and null is equal to a plus 1 into 1. And identity law: a plus a, anything is given, then automatically the same value is getting the output. And complement law, the complementary 0 plus 1, a plus a dash equal to 1, a dot a dash 0 into 1 0, so like that it will be displayed. Inversion law: a dash whole dash equal to the power has been cancelled, so a will be given. And theorems: commutative: a plus b equal to b plus a, same. Associative law: a plus into b plus c equal to a plus b. So these are all when we add more number of devices at the same time, then we can use this associative law: a dot a plus b plus c. Suppose b and c is one device and a is another device, means then we can add the same operation as a plus b plus c. Like this it will be formed. And next one is distributive law. Distributive means automatically it will be forwarded: a dot b plus c equal to ab. So the same example, that the two devices can be configured, or it will be possible based on this equation AB plus AC. Absorption: A plus AB equal to A. So like this, redundancy law will be used for reducing the errors. AB plus A dash B equal to B, because only one connection we need to check for this one. And absorption means which one will be happen the entire calculations. De Morgan's law. So these two laws will be used to generate more number of applications based on the NAND and NOR applications, especially for theorem 1 and theorem 2. A dot b whole dash equal to a dash plus b dash. So like that, a plus b whole dash equal to a dash dot b dash. So these two theorems will brings more NAND and NOR applications. Universal gates. So NAND and NOR will be acted as a universal gates, because it will provide and it will connect more number of devices at the same time, so that the NAND and NOR gates will be act as a universal gates. And the techniques: algebraic methods. Algebraic method is the same Boolean method: a dot b equal to a plus a dot b dash equal to a. And Carnot map also we use it because we are using here 2 to 6 variables. Especially for 4 variables, we may use this Carnot map. For more than 6 variables, we can use Quine-Mikulski method for tabulation method, and it can be used for calculating more number of input devices. It is a prime applicants. Next one is software tools. After finalizing all the values, we need to check the input and output signals by using this Logisim, Xilinx, and Quartus application softwares. applications. Most probably, these logic and minimization techniques can be used for Intel, Texas, Qualcomm, Siemens. So these are the standard companies which will be acted, and it will be using a sensors based on the logic minimization techniques. Assessment. In the context of an IoT based smart temperature controller, Y is minimizing a number of input variables in a Boolean function, crucial for embedded system design. So instead of using f equal to a dot b plus a dot b dash, because it's a two variable input signal, so that's why they are given about two inputs and two AND gates. Minimizing it equal to f equal to a, because the final answer is a, so that we can minimize those two input signal as f equal to a, so that the hardware will be implement the function will be very fast, and most probably it will be forwarded to the next signal without any delay, so that we can make it as a minimization techniques. Thank you.